We built the hardware for our LoRa receiver and web server. And next we need to develop the software. We will use the Arduino IDE to program our ESP32 board. We had about 10 episodes filled with a ton of interesting topics where we covered everything that is marked in green color here. My followers know that there is often some more added value coming together with the episodes. It can be experiments, results and tools in the download section. Now the software build for our receiver and web server is on our agenda. We want to realize an always-on program with our code based on a conventional endless loop. It shall receive LoRa signals whenever they arrive. The serial interface is used for debugging information and for technical data. For the data storage, a first in, first out memory principle is used because we want to realize a floating evaluation of our data. A web server creates a browser interface, which is a simple table that can be adapted easily in case we want to change or extend the data to be presented. This solution allows us to copy and paste the information directly to a spreadsheet where we can evaluate our data. The main requirements. As said before, we want to continuously receive weather data via LoRa. Our software needs to control and process the received weather data, the battery voltage, the sensor IDs and keywords. We need to store the current incoming values, the 24 hours minimum and maximum, the 24 hours data and the average per day for the whole year. In addition, there is some technical information to process. It will be the LoRa RSSI and the signal to noise ratio, the LoRa radio frequency correction, the uptime of the server, status information, etc. Going on with our software requirements. We want to connect our web server to our local Wi-Fi network and of course manage our credentials. The function that I called scheduled Wi-Fi sleep mode means practically that we can define an automatic switch off time in the evening and a wake up time in the morning. Of course, the LoRa receiver and the data processing needs to run continuously, also when the Wi-Fi is switched off. Since we want to log our data over the whole year, we need a precise time base. Our board cannot manage this. However, since we are connected to Wi-Fi, we can get time and date from Internet NTP servers. This is even for free, as long as we have only a few requests per hour. Then we want to indicate a 3 hours tendency indication derived from the air pressure measurements. And we want to bring all the data to a web page so that we can display them with a browser. Now let's see what we should get on a PC browser. I showed in an earlier video how to copy and paste this into Excel and further evaluate the data. Today I want to explain in more detail what we see here, because this will help us a bit to better understand the code that we will talk through later on. Our web page is rather technical and just straightforward without any fancy graphics. It shall be open for easy adaptations or extensions. We only work with pure numbers and text. I need to apologize for the German language here. However, you can adapt this in the code to your own needs. Let's get to the meaning of the content. The headline is self-explaining. It just shows the flow of the sensor data. We can always update all the data by clicking the page reload function in our browser. In the headline of the first section, we have a symbol for the air pressure tendency. The smiler at the end of the line can either have bright eyes with stars for rising pressure, or it can have tilt eyes for falling pressure. In the case of constant pressure, the eyes are dashes. In the section, we get the current values from our sensors. From the sensor in the server case, we get a new value whenever we update the page. The LoRa sensors are sending updates every 3 minutes only. The internal memory and the OLED display of the server is updated every 5 minutes. We get the temperatures here. The next column is the humidity, and the next one is the air pressure. Here are the LoRa SSIs of the received signals, and this is the battery's voltages. The last two columns are giving us a time and date stamp for each measurement. This is very helpful because in case of any failure, we have to prove whether our values are up to date or not. In my case, LoRa signal failures were very rare. Once it happened to me that a sensor ran out of battery. I could see from the last timestamp when exactly the last message was received from it. The next section is giving us the floating extreme values. They give us the minimum and maximum values from the past 24 hours. The next section gives us the measured values of the past 24 hours each. The first line shows us the value from 1 hour back, the second one from 2 hours back, and so on. In the last column you will find always the timestamp of the hour. In the next section we find the daily average values for each day in the year. In the last column we have always the date stamp. Then, going all the way down to the bottom of the page, we find some technical information there. We have the status of our scheduled Wi-Fi sleep mode, the time when it goes to sleep, and the number of hours to sleep. The next columns are the uptime of the server in days, the RSSI of our Wi-Fi network, the LoRa signal to noise ratio, the LoRa frequency error correction, and the version number of our software. We understand already from the requirements of our software for the receiver and the web server that it is a lot more comprehensive than the software for our sensor entities. It is far more than 1000 lines of code. Okay, I cannot impress professional software developers with that number, but anyway, if you consider about 10 to 50 lines of code per developer and day, it corresponds to a considerable effort. It will take more than one episode to cover it completely, because there is a number of functions to cover. And here I'm having an important hint for you, because you cannot read from the code in which order it was developed. It makes a lot of sense to have a proper structure that you can oversee and a proper strategy to develop the software. This is not only to reduce errors. A proper structure helps you to stay on top of things so that you know the next day what you have done before. Let me have a word on how I developed this code. As a basis, it is always good to start with small examples. I found a lot of helpful code from the Arduino examples library, from the Random Nerd channel and others that I modified and extended for my purpose. First, I developed the code for the LoRa receiver and the serial communication. The serial output was very helpful for some basic tests and debugging. The next step was the programming of the OLED display, the data processing and the data arrays. Finally, I added the code for the Wi-Fi and the HTML part for the web server. And now I have another important hint for you. I did a lot of pre-testing with simulated weather data, so that I could run the data processing very fast. With that trick, it took me only minutes instead of days or months to populate the arrays with data that I could process and display on the web page. This was extremely helpful for debugging almost the complete code, including the web page. Let's start with the actual code now. In the top section you find a lot of information and thoughts that I had during the software development, which I want to share with you. Don't worry, it is just my notes about progress, errors, corrections and some insights. Of course, you can skip it if you want. As in a usual code, we find a number of definitions and include libraries in our header. We need to include libraries for the BME280 sensor and the definitions for the pins we want to use. Then we have a library to get NTP time and date requests. Next, we have the definition for pin 37, which is used for our Wi-Fi sleep mode switch. Then we have some strings defined to indicate the Wi-Fi status and the pressure tendency that I explained before. There are some additional string variables defined for other trends that are not used yet. Here's the switch off time and the number of hours to sleep for our scheduled Wi-Fi operation. Then there is variables to process the sensor data. Here is the topographic height level for the sensor, which is needed for the air pressure normalization to sea level. We know that already from the sensor entities code. Then we have the libraries and definitions for our LoRa transceiver and the OLED display, followed by the pins definition for LoRa. This is the frequency band definition for LoRa, and again a number of string variables to be defined here. Next, we need to include a library for Wi-Fi, and again a number of variables to be defined here. Now we come to the variables that are dedicated to process the data. and here is a number of arrays dedicated to store and display the data. Then we have the headlines definitions for our web page. You can change them to any other strings you want to see on your web page. Then we need to define a port number for our server. The next lines would define switch functions on our web page. However, they are not used yet. Now we covered the definitions, the variables and the include libraries for our receiver and web server code. I explained the most important parts. We stop here because it would be too ambitious to cover all the rest of the code in one video. The summary of part 1. We defined our concept and the requirements for the software of our receiver and web server. The web page requirements were explained in detail. Some hints on the structuring of the code and pretest simulations were given. On the code, we covered the header part with the definitions and the include libraries. Hope you enjoyed this episode, and in part 2 we will complete the software coding of our LoRa receiver and web server. Now stay tuned and don't forget to subscribe and support the channel. See you soon in the coming episodes.